Hello and welcome to the OAISYS installation training course. This class is generally geared towards reseller partners who will be speccing out, installing, and configuring OASYS call recording solutions. The topics covered in this course will include the following. First, we'll be doing an OASYS recording overview to take a look at the different ways that you can record calls inside of an organization and the pros and cons of those different tap types. Secondly, we'll be taking a look at the various server specs that you can provide for the customers, from our turnkey server solutions to the software-only options which can be provided by yourself and the customer locations. Thirdly, we'll be taking a look at the various software options that you can use inside of a company to record those calls. You might have heard of us in terms of our Talkument and Tracer software, and this is where we'll be doing a discussion of those different software options. Next, we'll be taking a look at the various installation models, the ways that we physically record calls inside of a company, and how we physically get the server connected to record those conversations. Last but not least, we'll be taking a look at the basic configurations that are necessary in order to program the server and get it recording calls and working in its most basic form. However, before we start those discussions, I have two quick niceties for you. First, I want to introduce our Jumpstart program. Anytime you sell an OAISYS call recording server, a member of the OAISYS team is going to be in touch with you and ask when you plan on doing that cutover. If you give us heads up as to when that cutover will be, generally 1 to 2 weeks in advance, we will dedicate a member of the OAISYS tech support team to help guide you through the installation of your OAISYS call recording server for your customer location. There will literally be an individual from the tech support department on the phone with you in real time, generally remoted in, provided that the network accommodates, and they will walk you through the steps of getting this system configured and recording calls. This service comes at absolutely no cost and is recommended for all OAISYS installations until you get comfortable working with the servers. Another resource that we're going to provide with every single server that we ship is an OAISYS Quick Installation Guide. The Quick Installation Guide will come packaged with an OAISYS call recording server, but is also available on our website at www.oaisys.com. The Quick Installation Guide is simply a step-by-step instructional document that will take you through all of the various steps that we're going to be discussing in this installation course. It's a very handy resource to have by your side as you go through the installation. It will provide all your screenshots, installation models, and all the general information that you're going to need in order to program this system and get it up and recording calls. I like to mention those two things so you know some resources that are available and you don't feel the need to take a ridiculous amount of notes as we go through our installation training course together. That being said, let's go ahead and start talking about the OAISYS recording overview and the ways that we can record calls here at OAISYS that you might want to use for your customer locations. The model that I have in front of us is just a nice little 30,000 foot architectural model to show you the various ways that we can record calls, and again, the pros and cons of those different recording options. To get our bearings for this installation model, let me start off with some very basic telephony. What I've just drawn for you is a phone on the outside world. That phone is going to come into a customer location. It's going to hit a PSTN, your Verizons, your Sprints, your AT&T, whoever they pay their monthly phone bill to. That call is going to hit a trunk. It's going to get passed into a PBX or a phone switch, and that call is going to then continue to pass along to the individual inside of the organization so that they can have their lovely conversation back and forth. Extremely basic telephony. Where OAISYS comes into play is that we can record those calls in quite a few different ways. First and foremost, and probably the most common of our recording configurations, is that we can tap off of the physical trunk. T1, PRI, E1, BRI, analog lines, any sort of physical connection that might be coming into an organization. When we tap off of the trunk, we get a very beneficial thing, and that is cradle to grave recording. I call it C to G. Which essentially that means that we're going to be recording the entire life of that conversation, from the second it comes into the company until the last second that it leaves the organization, and everywhere in between. All the different extensions that it talked to, even recording that hold time while the individual was put on hold. You can go back and see what they were saying about you when they didn't think that they were being recorded. So we get the entire cradle to grave calling experience of that caller. Another option that we have at OAISYS is to simply record calls on the station side. Oftentimes this is done via digital key set punchdowns, can also be done via VoIP configurations, but essentially we're looking at the phone itself. So we're only recording the call when it passes to a given extension inside of the organization. Extensions that you'll choose and determine ahead of time that you're going to physically tap onto. The key with this sort of configuration is that we're only going to record calls when they hit those given extensions. So if we're recording the president and the vice president and the CEO's extension, but we're not recording the HR extension, we'll only be recording the calls inside of the company when they hit those given key sets. As soon as it would get transferred over to the HR extension, that phone would not physically be tapped, so we would not be recording that call. We're only looking at those given key sets inside of the organization. A benefit of doing digital station recording is that we can oftentimes record intercom calls. An intercom call is a call that takes place from one extension to another extension inside of the organization. And as you can see from the model that I just drew here, an intercom call traditionally never reaches an outside trunk. So we wouldn't be recording the call if we did a trunk tap, because that call never goes inbound or outbound through those given trunks. However, if we're recording at the station level, because we're monitoring that actual key set, we can record those intercoms because we're actually tapping on the phone itself. That simple functionality oftentimes will lead people to the digital station tap or will lead them to the trunk side recording. Aside from that, it's generally a function of economics. Sometimes it just makes more financial sense to tap on the trunks because they'll only have 1 or 2 PRI coming into the organization and have 500 phones that are coming off of those 2 T1s or 2 PRI. Other organizations might have 20 T1s and PRIs coming in, but they only need to record 10 phones on the sales floor. So it makes more economical sense in that configuration to tap onto the 10 actual physical phones than it does to record all those 20 T1s or PRIs coming in, because those phones could be taking calls from any given one of those trunk lines. So it's a function of economics and also a function of functionality as to which type of recording you would like to use inside of a company. There is the availability for redundancy as well, so keep that in mind. If you wanted to record 2 PRIs or T1s, but then also record a couple stations inside of the organization so that you could get that intercom functionality, you certainly could. You would just need to make sure that the server was licensed and equipped with all of the hardware and software that it needed in order to tap onto those physical trunk lines, and then also have extra voice port licenses to record those stations themselves. So it's not necessarily mutually exclusive. You can get the benefits of both worlds. And last but not least here on the diagram, we can also do VoIP recording. VoIP is also considered station recording as well, but the key with VoIP recording is that your phone could be anywhere in the world. Here at OAISYS, we have extensions in Baltimore, Seattle, California, and spread all over the United States. They're to us just another extension on the phone switch. So I can record a VoIP extension just as easily as I can record any digital station inside of the company, so long as we're licensed appropriately. VoIP extension recording has the same properties generally as digital station recording does. It's just that VoIP recording is generally more software based. Digital stations require physical connections, punching down to a 66 block or a 110 block, as we'll see in the physical side here momentarily. Those digital stations also require additional hardware, where VoIP stations generally do not require any hardware on the server itself. So those are the 3 primary ways that we can record calls at OAISYS. We can do trunks, we can do digital stations, we can also do VoIP stations. Pick whichever's going to work best for your company. The only other thing I want to point out on this installation model, why we have it handy, is this data stream that we have connecting from the PBX to your OAISYS call recording solution. This box down here below is the OAISYS call recording solution. Never mind the boxes, those are the bits and bytes that make our server do what it does best. So I just want to point out the things that are going to be most critical to your installation. That data stream that we get from the PBX is going to give us a lot of information about the recordings. And there are several different types of data streams that we can have. Generically speaking, they come in 2 flavors. There's a CTI or OAI based information stream, and there's also an SMDR based information stream. The CTI based information streams are your real-time information streams, And those give us a lot of robust information about your calls and also give us some beneficial functionality with your recordings. Those CTI or OAI streams go by several different acronyms, but generally speaking, those are your Intertel, Mitel, Toshiba, ShoreTel, and Avaya phone switches. There are some exceptions to that, but those are your generic families. That CTI or real-time information stream that we get with those manufacturers will give us a lot of extra information about recordings. So we're going to know things like the extensions that touch the call, the ACD agents, the ACD groups, account codes that were attached to the recording in real time. Lots of information about the call as it's taking place inside of the company, including the various extensions that it would touch during the life of that call. That CTI or real-time information stream also adds the functionality of our OAISYS desktop client. That desktop client is reliant on a real-time information stream so we can do things like start and stop the recording on the fly, or attach information to your calls as they're taking place inside of the organization. The one exception to that is a Vox tap type. If we're recording based on the detection of audio, which will also be another thing that we talk about in this installation course, we can use the desktop client as well to start and stop recordings and attach information to the calls. Otherwise, it's dependent on that real-time information stream that we get from the PBX. The other major type of data stream that we have is an SMDR link, and there are numerous phone switch manufacturers and makes and models that take advantage of the SMDR link. The SMDR link also gives us a tremendous amount of information about your recordings. Information like the extensions, account codes that were attached to the call. But the difference with an SMDR stream is that it's an after-the-fact data spill. So we don't get the information from the phone switch in real time. Instead, we're waiting for the call to end, at which point the phone switch delivers all the information that it can about the call that's just been completed. The general nature of SMDR is that we're going to get the last out of the phone switch. So if a call were to travel to several extensions inside of the company, the last extension that it spoke to is the one that will be reported on the call. Very similarly, if we attach information to the call, the last piece of information that was attached to the call, maybe in form of an account code or other sort of node information, is going to be the one that reports to our system. So whatever came in last off that SMDR stream is what our system is going to acknowledge and account for on the call record. If that data stream is missing, we can still record calls. We record anything and everything. However, you're just going to be more limited in the information that's going to be available on that recording when it comes to searching purposes. So even without a real-time information link or an SMDR link, we can still capture the call audio, but you're going to be limited to searching on that call based on things like date, time, direction, and duration. That information will still be available on your call records. We're just not going to see things like associated extensions or ACD information, account codes, or other things that might have taken place during the recording that would be reported to us by the PBX. So oftentimes we can use that no integration, but the higher level of integration that we get is going to give us more information about the calls that are taking place inside of your organization. So those are the two primary things that we're going to discuss in our installation today. One, how we're going to get the actual audio accounted for in our system, and two, configuring that data stream to get all the information that we can about the recordings that are taking place inside of the company. With those two things programmed, your system is essentially set up and it's capturing calls in its most basic form. So, with that quick discussion then about the general architecture and the ways that we can record calls inside of OAISYS and the important things about those configurations, the next thing I wanted us to discuss are the various server options that we have to actually pull off this call recording. Now, with OAISYS, we have several different families of hardware options that we provide. These are our turnkey server solutions to record calls inside of an organization. The three major families that we have are first our appliance varieties, second our tower servers, and third are big rack mount industrial servers for larger organizations. So we'll travel through all three of these different families. I'll show you what each is capable of doing and why you might want to use one inside of an organization as opposed to another. So the first flavor that we have are our appliance varieties. Now, our appliances come off the shelf as they are. They're built to do the same thing in every single scenario. There are 3 different types of appliances that we provide. And just like you would go to your local retailer to pick a toaster off the shelf, you take it home and you know it's going to toast your bread, our appliances are built very much the same way. Take them off the shelf, they know they're going to do the exact same thing in every single configuration. The first of our appliance flavors is what we refer to as the flagship. This is a little 1U rack-mountable unit that can record up to 2 T1s or PRIs. It comes equipped with a dual T1 PRI board and licensing to handle all of those T1s or PRI ports. That's 48 total voice port licenses. This unit can also be used for VoIP recording. So if you want to mix and match, you certainly can. Maybe an organization has one T1 coming in and they also want to record a few additional VoIP extensions. By all means, they can mix and match however they'd like. It comes licensed with those 48 ports. This unit is also expandable to 100 VoIP ports in OAISYS version 7, so it can be licensed additionally if it's strictly a VoIP recording solution. If it's going to be based on hardware, it is capped out at those 48 ports because all we put in this is a dual T1 PRI board, so expansion would be on the VoIP side. This unit can handle 56,000 hours of online storage internally. With overflow destinations like NAS or SAN locations, that can be expanded upon on the network, but inherent to the server is 56,000 hours of online storage. The second of our appliance varieties is what we call the small office appliance. This solution is strictly a VoIP recording appliance. It's spec'd out the same. It's a 1U rack-mountable unit running on Windows 7, but this comes licensed with just 20 audio ports for VoIP recording alone. It does not have a dual T1 PRI board in it. In fact, there is no hardware for call recording whatsoever built into this server. It's strictly a VoIP appliance. This also is expandable to 100 VoIP ports if you would need to expand the unit, and holds 56,000 hours of recording inherently. Last but not least, still a 1U rack-mountable unit, we call our analog appliance. This appliance does have a hardware board in it. It's an 8-port analog board, so we can record those POTS lines, simple analog lines. This unit also comes licensed with 20 audio ports. We can record up to those 8 analog lines, but can also be expanded for VoIP use. So if need be, this records VoIP out of the box and can also be expanded to 100 VoIP ports if an organization would want to do VoIP recording as well. This, as with the others, holds 56,000 hours of online storage. So those are our 3 appliance types. Turnkey server solutions that come off the shelf as they are, and they're going to handle those 3 different call scenarios. If you would need to expand beyond that, we get into our custom-built server options. The first of our physical boxes when it comes to custom builds are what we call the standard server. Now, this is traditionally a tower server that runs on Windows 7. Hardware limitations for recording on this box are up to 48 ports, but you can mix and match that however you see fit. If an organization has one T1 coming in and they also have 4 backup analog lines, this is the server make where we start opening up the box and equipping it with the hardware that it would need to pull off recording for the customer location. We could put a single T1 PRI board in there. We could also put an 8-port analog board in there, close it back up, ship it out, and it would be capable of handling all of those ports. But based on hardware limitations, it's only going to record 48 ports of activity. If you would like to do this as a VoIP recording server, it can also record 100 VoIP ports, but that's the limitation if it's VoIP recording only. If based on any sort of hardware limitation, we cap it at 48 ports. Like the appliance varieties, this server holds 56,000 hours of online storage native to the box. And in addition to the appliance varieties, here's where we start giving you physical CD or DVD backup capability. So there's a burning drive on the server that you can stage your recordings to, and we can keep those calls in a CD or DVD format in a hard copy. And this box also opens up the availability of RAID option. We can get RAID 1 on this box, which is full disk redundancy. It's duplicate drives. Those drives are hot swappable, so if one of the drives were to fail, we have a secondary drive that would kick in and it would continue with the recording of those calls. The last of the flavors that we have are advanced servers, and these are big 4U rack mountable units that are built for industrial recording solutions. This box runs on Windows 7, and this handles up to 96 physical ports. So now we're talking 4 T1s, 4 PRIs. We can put 2 dual boards in this, or mix and match any other hardware that would be necessary for the customer location with a cap of 96 ports. So maybe they have 3 T1s come in. We could put a dual board in there, a single T1 board in there, and then also put an 8-port analog overflow board in there for those overflow lines that would come in via analog lines, or if they're doing any sort of radio recording. So we can mix and match the hardware to meet the customer's location, so long as physically we don't exceed 96 ports. If this is going to be an IP-only solution, we can do up to 200 IP ports with version 7 on this particular box. So now we're expanding the port capability by moving into a more industrial server. This box is going to hold 100,000 hours of recording native to the hard drive. It still has the CD, DVD drive on it for physical burning, and it has RAID 1 available as well. And last but not least is our most resilient of servers, called the Advanced Plus. The Advanced Plus is also a 4U rack mountable unit. This server, though, runs 2008 server software. So we're no longer using the Windows 7. This is a full-blown server OS. It can handle up to 192 ports if we're doing physical recording. So we're talking 8 T1s, 8 PRIs. We can put 4 dual T1 PRI boards inside of this server. If this were just for VoIP recording, this server can do up to 350 VoIP ports on OAISYS version 7. It can handle 200,000 hours of recording native to the hard drive. This box has a full SQL Server database, which is a very nice mentionable, in that it can keep call recordings for an indefinite period of time. The previous versions of servers that I've just shown you are all based in SQL Express. The SQL Express has a cap of about 1 million call records. So if beyond 1 million call records, we start losing visibility to the calls themselves when you go back for searching purposes. Now, 1 million call records is a whole lot of recordings, and for most organizations, that's going to be certainly more than enough. But for companies that do a really high call volume, having the full SQL Server database on there allows you to track recordings for an indefinite period of time. The full SQL Server can track calls 3, 4, 5 million in record. So if we're doing a really high call volume and you need to keep calls accessible for a longer period of time, this server coming with the full SQL Server database is advantageous. This box also has CD or DVD backup capability. It does have a redundant power supply, so maximum uptime, and it comes available with that RAID 1 option, as do the other custom build servers. Now, OAISYS is not by any means limited to just the size of an Advanced Plus. Opportunities that are beyond 8 T1s or 8 PRIs, we can network together these servers in sort of a master-slave configuration and have them speaking to each other. So if an organization were to have 20 T1s or PRIs coming in, we could simply stack these Advanced Plus boxes on top of each other and have them network together, writing all the call records to one major box. This would be your master, and the others would just be working as slaves. If anybody wanted to listen to recordings that happened on any of those boxes, they would simply connect to the master server, where they would search for the call through the SQL database, and it would find the recording for them, whether it was on its own hard drive or if it was on a slave location. It would then stream the call back to you seamlessly. You would be listening to that call in computer time, we're talking milliseconds, oblivious as to where the call was streaming from. So that master-slave configuration can make our servers expandable to any size location that's out there. Another advantage to this master-slave configuration, these trunks can all be coming into one location, or they can be spread all over the good earth. We could have one box in Cleveland, we could have one box in Orlando, and we could have another one in San Francisco. we're not bound by any physical limitations. So we can set these up via network, traditionally a tie line or an MPLS, and we can have these working in a master-slave environment where if I want to listen to any of the calls that came in at any of my locations, I could just connect to one box and be able to surf all of the recordings that happened at all my different locations off of that one SQL interface. It would then find for me the call that I wanted to listen to at whatever location it was located at, and it would start streaming me the audio that happened, whether it was on that master box I'm connected to or any of the slaves that were dangled off of that box. So there's lots of expandability, lots of flexibility with OAISYS call recording solutions. We can network these together, and we can accommodate any sized organization's recording needs. In addition to the audio recording servers that we custom build and ship from our headquarters, we also have a screen recording server. Now, the screen recording server complements any of our tracer call recording software packages. And what this server can allow your customers to do is record the desktop activity that's taking place on their PC while they're on the phone talking away with your customers, your VIPs, whoever they might be chatting away with. When we get an event from the telephone telling us that that person is off hook, our screen recording server can simply start taking captures of their desktop activity. Once that call is then hung up, we merge that screen capture video stream with the audio of the call, making one full record that can be played back, and in harmony I can listen to the recording and also see the desktop activity that was happening on my agent's PC. Whether they were using the internet appropriately or inappropriately, playing Minesweeper, Solitaire, or typing in the credit card information and using the script as I told them to use the script. So the screen recording server is a nice complementary piece to any tracer recording solutions. The server that we ship out of house is one of the 4U rack mountable servers running that Windows 2008 server software. This does integrate with all tracer call recording servers, but it needs to be dependent on some sort of data connection. Traditionally, pre-OAISYS version 7, this had to be used in a CTI environment, so where we had that real-time data capture from the PBX speaking with our server so that we could know when the agent was off hook, when to start the recording, and when to stop the recording. However, now with version 7, it's not dependent on that real-time data stream. Screen recording can also be done in a Vox environment where we're detecting and recording the call based on audio presence. It can also be used in a predictive dialer integration with our API, and it can be used in a desktop client integration, again using our API. If you have questions about whether or not screen recording is going to work for a customer location, by all means, call into our sales engineering team. They can work with you to see if we can get screen recording used in conjunction with audio recording for a customer location. But now it is no longer dependent on a CTI stream. There are other ways that we can do screen recording with OAISYS version 7 and beyond. The server that we ship out of house comes with a 1 terabyte hard drive. That 1 terabyte hard drive is going to record about 1,000 hours of desktop storage. Generally speaking, desktop recording video is something we're going to look at in the near term. So 1,000 hours generally accommodates most locations. However, just like with audio capture, we can do network storage of that video recording. If you'd like to keep calls beyond the shelf life of the server and get more than 1,000 hours of desktop video storage, we can certainly start overflowing those video captures to a NAS or a SAN, some sort of network location, and keep as much video recording as you'd like. The desktop recording server is statically tied to specific agents that you want to record. When you configure and install the screen recording server, there's actually a client piece of software that you'll put on the computer of the agents that are being recorded, so we have to statically tell the server which agents inside of the company we want to start capturing. Any given box can record up to 96 agents, so you would specifically choose those agents inside of the company who you want to record when they're off key set, and we would actually start the video capture of those calls. As a little FYI, we don't actually take a stream fluid video capture. What we do is actually take screenshots based on the rate of change. So if the agent's looking at the same screen for the entire life of the call, that video capture is actually going to be very small. We're taking 5 flashes a second, noting any change that's happened on their screen. If they're watching a YouTube video, that rate of change is going to be rather drastic, so every time we take another capture of their screen, there's going to be a lot more change and there's going to be a lot more data for us to record. So that 1,000 hours of desktop recording storage that I mentioned earlier is going to flex depending on what your agents are doing on their screens during the life of that call. So what we've just looked at are all of the physical servers that we ship out of Office that are our turnkey recording servers or our turnkey screen recording servers. There are, however, other options that have been introduced at OAISYS. One of them is a software-only option. Software-only options can only be used when no physical hardware is required to record calls. So we're talking VoIP or SIP installations. If we have to do any physical connectivity, tapping onto a T1 or a PRI, analog lines, punching down digital stations, or anything else that's going to require any physical connectivity, that would have to be purchased through us as a turnkey server solution. If no physical hardware is required for a tap, that would lend itself to a software-only installation. If we're going software-only in those VoIP or SIP configurations, there are a few things that would need to be done for yourself and the customer who are providing the servers. First, we'll talk the standard software only. Then we're going to talk VM. We are VM capable, so we can do virtual machine server installations as well if we're going the software only route. Standard software only installation. One, you need to make sure that the server meets minimum specifications that are put here in this diagram. This same diagram is available in the quick installation guide that we mentioned as we began the course, but make sure that the server is going to meet these minimum specifications. Once you've found a server that meets minimum specifications, we also need to make sure that it has the appropriate hardware equipped into it. For any sort of VoIP or SIP installation, we need to have two things physically ready. One, we're going to have a server that has 2 NIC cards, so it needs to have 2 network interface ports provided on the server. And 2, we're also going to need a network switch that has port mirroring capability, which is a physical component of any time we're doing any sort of VoIP recording. The exceptions to that are the Mitel SRC or recording via ShoreTel Tappy Wave integration. Otherwise, we need to have those 2 physical things on premise or built inside of the server so that we can record in this software-only installation. If we're doing a software-only installation, there is some prep that will need to take place in order to get that server functioning like an OAISYS call recording server. All of the software that you're going to need to build this server to spec is going to be provided in a DVD that will be shipped to you on the software-only installations. That DVD is going to have all the software that you're going to need to install in order to get that server up and running and functioning like an OAISYS call recording server, with just a few exceptions. One, you need to make sure that you have an OS, the full-blown OSs, Windows 7 or Server, depending on the style of recording that we're doing, and we need to make sure that it's updated with all of its service packs. While we're installing, you need to be sure to enable IIS, ASP.NET, and active server pages, which essentially help to host a web page that the server is going to provide where you download the OAISYS server to all of the computers that are going to need to connect. Instructions about installing that appropriately can also be found in that quick installation guide. Off of the DVD that's provided, you'll need to, on the server, install the .NET framework, which is what our software is built upon, a USB driver, connect to a dongle, audio codes driver, if applicable, the SQL Server software, which needs to be installed very carefully, which is again step-by-step mentioned in that quick installation guide, and then also install the OAISYS recording server software, which allows our server to function like an OAISYS call recording server. All of the steps for that software-only installation are in the quick install guide. Just follow that step by step. It will take you through the prep side of the server. If we're working in a VM scenario, virtual machines, we would, one, want to make sure that the server meets all the minimum specifications, which are again mentioned in that quick installation guide. Assuming that we have a VM partition that meets all those minimum specifications, installing and prepping the server is rather quick and easy in an install for VM. we will actually provide an image that's called an OVF template on a DVD that will be shipped to you whenever there's a virtual machine installation. All you need to do is drag and deploy that OVF template to the partition on the virtual machine. Once that's done, you create a USB controller in that VM partition, which will allow us to connect and get all of the license information that we need in order to continue having that server run as necessary. If we're not running a current enough VM version, you can also use a Digi Anywhere device, and we'll ship you a physical dongle that you'll connect, dedicates a port through VM, a little USB port, where we can read our license information and allow you to function and continue to record calls. So how you will read that USB information is going to be dependent on the version that you're running. If we need to, we can use that Digi Anywhere device to connect to that USB physical dongle, or we can just create a fake USB key and controller on the VM partition, and that will connect and give us our licensing information. So, virtual machines, very quick and easy. Deploy the template that's been custom built, run that, and have the VM partition now function like a full OASYS call recording solution. One other thing worth mentioning for those of you who are going to be using VM installations. We do support vMotion, which essentially allows for multiple instances of redundancy for maximum uptime. So if we're doing any VM installations, know that we support that vMotion for that redundancy and maximum uptime. All of that then kind of covers our different server specs. You can either purchase a turnkey server solution from us direct, or we can go ahead and do a software only or VM installation for those VoIP or SIP models where you can provide the server or your customer can provide the server, and then you can just install the software to have it ready to function as it needs to be ready to function. Once we have that server then spec'd out and chosen to record the calls inside of the company as is going to be necessary, the next major determination that needs to be made is what sort of software option is this customer going to need. Now, you might have heard us talked about in terms of realms of Talkument and Tracer in the past. Talkument and Tracer are the two different OAISYS call recording software varieties. First and foremost, let's talk about Talkument, kind of a side-by-side comparison. Talkument is essentially our lightweight call recording solution software. It gives you all the functionality that you need to work with your calls that have been recorded. Back what people were recording calls for originally. I need to be able to go in and do my he said, she said games, my verifications. I need to find calls and have the functionality to listen to those, work with them, and get them to other people that might want to listen to them as well. That at the core is essentially our Talkument software. It's great for all companies who want to just go back for verification, he said, she said game purposes, and have their calls accessible. I certainly don't want to downplay its other capabilities. It's got lots of great productivity tools and elements built into it. It has the ability to put notes on a call, to collaborate and share those calls with other people. I can convert them to WAV files and MP3s. There's simple navigation systems where I can store calls and make them easily retrievable again in the future. There are certainly productivity tools that make the Talkument software above and beyond most any other call recording solution out there. All systems that we ship and all software-only installations will come with an unlimited number of Talkument users on the server. So there is an unlimited amount of people inside of the company that can have access to recordings, whether it's just his or her own calls or every call inside of the organization, maybe even somewhere in between. And we can have as many people as necessary looking for, listening to, and working with your recordings as you would like. There is a next tier, though, to our call recording software, and that's called our Tracer software. We refer to Tracer around here as Talkument's big brother. It gives you all the same functionality that the Talkument software provides, but also adds a great deal more functionality for your managers and supervisors that make it a true management tool. Included among those things, you get the ability to run reports, so I can get statistics, graphs, charts, summative information about my system, and I can see how things are happening inside of an organization. I get employee evaluations, so I can quite literally grade my employees' calls. I can set up scorecards, and I can test them as to whether or not they're being friendly or helpful, nice, answering the customer's questions. Whatever sorts of things I want to quantify and teach to, I can set up evaluations to monitor the performance of my employees. And also we give you the live call monitor interface, where I can look for and listen to and work with calls in real time. So as opposed to having to work with your recordings historically or after the fact, I can now work with the system in real time, monitor what's happening at any given moment inside of the organization, and keep tabs on things as the business flows along. The tracer software, worth note, is based on a license count. So you can only have as many tracer users in the software at a given time as you have available tracer call manager licenses. Every server that we ship with tracer software comes with an inherent number of those manager licenses. You can't have as many people inside of the company set up to use the licenses as you would like, but only as many of them can log in at a time as there are available licenses. So if a server would come shipped with 3 of the manager licenses, you can certainly set up 10 people inside of the company to have access to that interface. However, only 3 could be logged in at a time. If a 4th tries to log in, he or she's going to get an error message. You've exceeded your call manager licenses, at which point they would need to wait for one of the first 3 to log off before that license would become available, and they could then log in. It comes on a first come, first served basis. Those call manager licenses are certainly available a la carte. So any given company can have as many of those call manager licenses as they would need at any given time. Just realize the dynamic that they are first come, first serve, so they really only need as many of those licenses as they foresee having managers logged in at any given time. That then are the 2 software solutions. They can either go with the Document software if they just need a lightweight call recording solution, or they can go with the tracer software if they need more managerial or supervisory tools to really keep tabs on things and how their calls are taking place inside of the organization. So that kind of takes us through the decision-making process. What does the company have? What do they need in order to pull off the recording of what it is that they have, those physical lines or those VoIP stations that they want to record? And once we physically determine what's going to need to record the call, what sort of software interface are they going to want to use in order to work with their recordings? What functionality they need to have with those recordings? That's essentially the sales side. We spec it out, we find what's going to meet their recording needs. Once the server's been shipped, or once it's been built on site for doing a software-only installation, now it's time to actually do the physical connectivity. We need to get this system up and running and recording calls. So what I have for us now are several installation models that are going to take you through the process of how we physically connect and how we record calls inside of an organization. The first one that I have in front of us is your standard T1 or PRI interface. Here's how we'd physically connect if we're tapping onto those digital trunks. Anytime we're doing a physical trunk tap, we are going to ship with that server 2 things. We're going to send a Y-jack splitter, and we're also going to send a crossover cable. Those are the 2 physical things that you're going to need in order to pull off the recording of a T1 or a PRI. Here's how this works. Very simplistic. It's probably the easiest tap that we have. It's going to take you about 30 to 45 seconds per line. From the network element, this is the smart jack. We're going to unplug the straight through cable that would traditionally be sent over to the PBX for the customer to have their conversations on. We're going to plug in this little splitter. We're going to re-plug in the straight through cable so we can get that line back up and running and they can have their conversations. And we're going to take the duplicate copy of all this call information via the crossover cable that we provide and plug it into the back of the T1 PRI board on the OAISYS call recording server. That's really all there is to it. It's like using a cable splitter to split the cable in your house. We're using this little RJ45, this Y-jack splitter, to split the audio line that would normally be running traditionally straight to the PBX, make a duplicate copy, send that duplicate copy down to the voice boards of the OAISYS server. Worth note, this is a passive tap. So if anything were to happen to the crossover cable, somebody's working around in the server room and accidentally unplugs it, we are not going to take down the audio of the whole system. We just simply wouldn't be recording it on the OAISYS server anymore. So this is a passive tap off of that line. If anything were to happen to this connection, if that were to get severed for any reason, your customer would still be able to have their conversation seamlessly. There will be required some downtime, however. So this is probably something best to do early in the morning, late in the evening, or when the customer can afford some downtime on their lines. Though it is minimal, because we are unplugging that straight through cable, we're talking 30 to 40 seconds of downtime per trunk line where they won't be able to take calls on those lines. Or if there are currently calls involved, they would be disconnected on those lines. So that's your standard T1 PRI connection. Very quick and easy. Again, generally takes about 30 to 45 seconds to actually do the physical connection of this server. At that point, you would mount the rails, put it in the tower, that box is physically connected and ready to be programmed to start recording some calls. The other installation models that we have, if we're doing digital stations, this is going to require some physical connectivity. So now we're going to punch down to a 66 block or a 110 block. We're going to actually do some connecting, some wiring of those pairs. So if we're doing a digital station tap, here's what this would look like. We're going to take the pair from that digital key set, and we're actually going to use a bridge clip, and we're going to punch it down to a 66 or a 110 block, and we're going to make a duplicate copy of that audio yet again. Because as you'll see with all these installation models, the key is that we need 2 copies of audio. One for the server, one for the PBX. So we're going to use this bridge clip. We're going to send 1 copy of that digital station audio to the OAISYS server, and we're going to send the other copy to the PBX where it would normally be. So we're just making a physical tapped connection off of those digital stations so that we have a copy of the audio for the OAISYS server. Traditionally, the back of the OAISYS server is going to be an Amphenol port, so we'd plug an Amphenol cable in, we would splice that Amphenol cable out, wire in the pairs, and we can record those digital stations. One thing to note on the Mitel 3300 digital stations, if we're tapping Mitel digital stations on the 3300, we require 2 ports off of the digital station board in order to record any given station. We have to have 2 of those to maintain the integrity of the D channel. So if we need to record 12 digital stations on a 3300, we would actually need a 24-port digital station card in order to record those. So every digital 3300 key set requires 2 physical ports off of a digital station tap board in order to record just that one phone. Every other one, it's a 1-to-1 ratio, so you would just need 1 of those digital ports for any digital key set that's going to be tapped down inside of the organization. Just one little mentionable there that wanted to make sure to note. So that's the wiring out if we're doing any digital station taps. If we're going analog, if we're going to tap onto an analog trunk line, kind of looks the same as doing any of those physical taps, but yet it also looks quite different here, I suppose. In order to tap onto an analog line, we are actually going to tap off to the tip in the ring, and we're traditionally going to wire those to a biscuit block. Now, here's a little biscuit block. We do not provide biscuit blocks, but you're just going to wire that down off the tip in the ring. This particular biscuit block in the model is shown tapping off of 2 different analog lines, so we can tap 2 analog lines on any given biscuit block, wire that in, and then we would just use a standard line here and run it to the analog board in the back of the OAISYS server. So this is actually what that 8-port analog board looks like on that Talkman appliance, that analog appliance. And any given port actually taps onto 2 of those audio analog lines. So wire it down, plug it into the analog board, we're tapping onto those analog lines. In a standard VoIP configuration, so this is standard VoIP. The 2 exceptions to this, as I'll show you in the model momentarily, are the 3300 with the SRC or any ShoreTel models. But all other VoIP configurations are going to go by what we call the standard VoIP connection model. Here's how we record VoIP in the world of OAISYS. We are going to need you or the customer to provide a network switch with port mirroring capability. That port mirroring capability is what we're going to leverage in order to record the IP information that we need to capture off of the phone switch. Here's essentially what's going to happen. We're going to send all of the IP traffic to 1 port on a network switch. If we have 2 different IP cards, we could certainly put 2 or 3 different lines here to different ports of a network switch. The model just shows all the traffic coming from 1 IP card. But we send all of that IP traffic through 1 port of a network switch. We then have a copy of all of the audio taking place inside of the company firing through that port of a network switch. We turn on the port mirroring capability, and we essentially clone all of that VoIP traffic to an identical port inside of the network switch. At that point, we now have two copies of all of the VoIP traffic that's happening inside of the organization. By using that port mirroring technology, we can then take that duplicate copy of all of the VoIP activity and send it over to the OAISYS call recording server. So this network switch with port mirroring is what's cloning all of that audio and giving us the duplicate copy that we can capture and record for the organization. Any OAISYS server that's doing this port mirroring technology is going to have two NICs in it. So we're going to have one to get it on the network, and then the other is actually going to be what captures all of that mirrored traffic so we can start deciphering and recording all the calls. So that's what I mentioned when we talked about software only earlier, that the server needs to have two NIC ports on it. Any server that we see going to do VoIP recording, we would ship with two of the NICs. If you're doing a software only installation and capturing VoIP, be sure that that server has the two NIC ports available. That's it. That's how we physically connect, leverage that network switch with port mirroring capability, take the redundant copy, send it over to the OAISYS server. In the world of the Mitel 3300, if we are going to use the SRC, there's a little bit of difference that we have here with an SRC configuration. The Mitel 3300 keeps all of its VoIP activity very encrypted. So assuming that we use that level of encryption that comes native to the server, we need the Mitel SRC to decipher all of that encrypted VoIP activity and send us a copy of that VoIP. When we're doing a Mitel SRC configuration, our system sends a certificate request over to the SRC, which is then accepted so that we can start connecting and recording that deciphered audio information. So the world of the 3300, if we're using that encrypted audio, is a little bit different in that we need the SRC mid piece to decipher that encrypted traffic and send us over a copy of that audio information. One other thing worth note on this, new to version 7 of the software and for all versions beyond, the OAISYS server can now connect to multiple SRCs. We can connect to multiple MyTie links. So we can have multiple SRCs under one roof. We can have multiple SRCs split over large amounts of land. We can connect off of one server to multiple MyTie connections, and we can record many of those. In server versions previous, we could only connect to one MyTie stream, which limited us to needing one server for each of those connections, and then we would network together our OAISYS servers. Well, now one server can connect to multiple MyTies, which allows us to connect and record many different servers off of just one OAISYS call recording server box. Additional information about that can also be found with our OAISYS SEs calling into our sales line. They can walk you through those configurations. In the world of a ShoreTel, it's also a little bit different when it comes to VoIP recording. In the world of ShoreTel, we set up what's called a route point extension. And that route point extension passes all of the VoIP activity from the ShoreTel to the OAISYS without the need of a port mirror. We're going to program that route point extension, just pass that VoIP activity directly over. The OAISYS server is going to record the audio. Also, just one thing to mention, there's some little extra piece of downloaded software on the OAISYS server, and any ShoreTel installation is going to require that full-blown 2008 server software as just a requirement of ShoreTel integration. Next thing that we have here in terms of physical installation, we can also do Vox recording at OAISYS. Now, Vox recording is traditionally looking for any presence of audio on the line. Traditional scenarios where we do Vox recording is where we don't have any integration with the phone switch and we just need to record calls. Oftentimes, as the model shows, this is used in radio traffic scenarios. So if we're recording calls for a 911 call center, police dispatch, ambulance dispatch, taxi dispatch, or bus communications, we can record off of an audio radio device and we can capture all of the calls that are taking place on those radio channels. However, Vox recording can also be used in many other scenarios as well. We can Vox record phones that have no integration off the PBX. We can Vox record IP packets, it's called RTP packet capture, where we're just looking for audio to be taking place off of any physical device. So there are lots of scenarios where we do Vox connections. Leveraging Vox, one additional thing that this gives us is the ability to use the desktop client. So if we don't have CTI integration with the phone switch, this is the other option where we can do that desktop client integration to start and stop recording of audios or to attach information to call. Because if we're looking for audio to be taking place on that device, we know when the key set's off and on hook in real time because we're monitoring and receiving those audio packets. So with Vox connectivity, let me show you how this is going to work. We wire out any specific thing, if we're doing a physical Vox tap, to a standard RJ11 jack. So if this is a radio device, this is the audio line coming out, we can splice that output audio line and wire it to a standard RJ11. Then we would physically plug that RJ11 into an analog board where we can then be monitoring it physically off of that hardware. As soon as we see that device come off hook, start taking voltage, we detect the presence of audio on the line, we start recording the call. Now, Vox has its own little nuance. We're only going to be recording calls when we see that presence of audio. When we see that presence of audio, we start to capture the call. Then, based on a programmable seconds of silence interval, we're going to determine when to stop the recording of that call. Those programmable seconds of silence range from 5 seconds to 15 seconds, and they can be customized per location. If we set that seconds of silence to 5 seconds, once we no longer receive any audio off of that device for a period of 5 seconds, we then stop the recording of the call and we consider that one conversation. When the device goes back off hook, when we again detect the presence of audio, we start the recording of a new call. Once 5 seconds of silence have passed, we then chop that and call it again its own recording. So, if any given conversation has lots of seconds of silence in amongst it, we could chop that one conversation into several different sections of a recording. It's all going to be recorded, but it might look like several different conversations. Vice versa, if that line is never quiet, if something catastrophic happens and the 911 dispatch is going off hook constantly, then we might just record that call as one 8-hour-long conversation day. We're going to capture all the audio that takes place during that 8-hour period on that line, but it will look like one long conversation because it never hit that moments of silence stopgap where we could then chop the recording and consider it one conversation. So that's how we break up the recordings, is based on those programmable seconds of silence. And last but not least, when it comes to ways that we can record calls, OAISYS can now record calls via SIP. When it comes to recording SIP, the way that we record is a little unique. We can record on the SIP trunks or we can record on the SIP stations, but it's a lot like capturing data via IP. We tap at the IP address or we tap at the MAC address. So calls are going to come in and we are going to tap off of it just like we would an IP station. We then capture all of the call activity on the OAISYS server. Inside the OAISYS server is a virtual board. There are lots of different SIP signaling protocols out there in the world. Lots of different ways that SIP passes audio. So there's a virtual board inside of the OAISYS call recording solution that can decipher all those different types of SIP signaling. We can then record the call as it's taking place on those SIP stations or on those SIP trunks. One thing that makes us truly unique is that we have a matching logic capability based off an SMDR spill, which will give us extra information about the calls that other providers cannot. So when the phone call ends, we get an SMDR feed from your Mitel, Intertel, Toshiba switches that currently support SIP. Others are currently in the works for doing so and testing right now. But we can get an SMDR feed that will tell us information about that SIP call that just took place. We then use our matching logic to match up the information that we know about the SIP recording and that the phone switch told us about the call that it knows took place to add additional information to your recordings, things like extension. So the SMDR spill will tell us a call took place at 11:05 this morning that lasted 31 minutes long and happened on Ted's extension. We then see that there was another call that happened at 11:05 this morning that lasted 31 minutes long, mesh the two datas together, and then provide information about the call on the record of the recording based on essentially our best guess. If no best guess is available, we simply disregard the information and don't attach it to the call recordings. But based on the fact that the information is so granular, 99% of the time we get specific enough information about the call scenario that we can take that SMDR data, mesh it with the call recording, and we can give you additional information about the SIP call that's taken place. If we record at the SIP station, it has the same properties as a station side Vox. So that would also allow us to use the desktop client, and we can do station side screen recording on those SIP stations if we record at the station level. That's not something that recording at the trunk level would give us, but if we do SIP stations, we have some extra real-time functionality that's allowed, which would give us that desktop client and also that screen recording capability. So the world of SIP is something we certainly record. We can do it on the trunks. We can do it on the stations. So what we've just then looked at are the different ways that we can physically connect. We can either physically tap onto those T1s, PRIs, digital stations, or analog trunks, and we can, via IP address or MAC address, tap onto IP stations, SIP trunks. Once we get those things physically installed, either by plugging the Ethernet cable into the NIC card or by physically connecting all those devices, we can then put the server on its rails, mount it in the tower. Now we can start the programming element, which gets it aware of what it is that it's supposed to be recording, get it connected to the phone switch, and have it start working in its most basic form. So, starting to work then on the configurations. Once we get that server plugged in and powered up, you connect a monitor, connect a keyboard, connect a mouse, we can then start doing the programming side of it. First things first, we need to tell the server what sort of PBX it's going to be integrating with. So once the OAISYS server has booted up, we would go to the services menu and we're going to tell it the type of SMDR or CTI integration to be aware of. If you right click on my computer, then go to Manage Services, you'll get a window like appears here on the right where you can choose from a list of installed services that phone switch manufacturer that we're going to be speaking with. All of them will be provided as a service. You simply turn that particular service that matches the PBX we're integrating with to automatic, and it's going to be prepped to know which sort of PBX to start speaking with. We haven't yet told it where that phone switch is. That step will come here momentarily, but we're just prepping it to know the style of communication to be looking for once we point it to that appropriate PBX. Once that service is started, all the rest of the programming that we're going to do is actually inside of the OAISYS server software. So you open up Internet Explorer, and there will be a launch page that opens by default. The piece of software that you're going to want to get to is the OAISYS Management Studio. If this page doesn't open by default on a software-only installation, the web address that you would want to go to is http://localhost. Hit enter, and it will display this page for you where you can download the OAISYS software. If you click on the Management Studio button to the left, that will pop for you the following interface. This is the OAISYS Management Studio software. The only username and password that's available to you out of the box is sysadmin. So you will log in with the username sysadmin, SYSADMIN, and the password of the same, SYSADMIN. When you log into the software, it's going to immediately take you over to the programming side. This is the administrative interface that you can use to get the system up and running and recording calls. Now, as I mentioned when we were looking at the diagram earlier, there are essentially two things that we're going to want to have the system do during this installation side. A, be aware of those things that we're going to record, the actual audio connection, and B, be aware of the phone switch so we can get extra data about the recordings that it's going to tell us. There are a few other things we'll look at, but those are the two most important things that we're going to program. So why don't we first look at that integration? How we're going to get the system talking to the phone switch. Well, this is going to depend on the actual make and model of phone switch that we're working with. Those phone switches are going to integrate either in real time via CTI connection, real-time data stream, or it's going to be an after-the-fact data stream, which is SMDR based. This will be one or the other. You'll never use both. If it's a real-time information stream from your Intertels, Mitels, ShoreTel, Toshibas, or Avayas, you would come to this little CTI area. Any SMDR-based information, you would come here to the SMDR service. So choose the appropriate one. If we're going to do a real-time, what we need to do is tell the system under port settings where to start speaking with the phone switch. So you're going to type in the IP address or the name of that phone switch that's under the roof. Once we get that connection presented, you can do it here based on the IP address, or again, just type in the name of the server. You'll actually see in the status tab that it's working. We're now speaking to that phone switch. Because we've already turned on the service to tell it what type of phone switch we're going to integrate with, now that it makes that connection, it's going to understand the PBX, it's going to start communicating, and you're going to get this working signal. So yes, I not only know that I'm going to speak to this make and model of manufacturer, but now I've begun that communication. We are now working. Life is good. The data stream with the PBX has now been connected. Our system's going to know about the calls that are taking place. Very much the same way if we're doing an SMDR. For SMDR, we come in here and tell it about the port, what type of PBX we're connecting with, and it would start that communication. It's going to start talking back and forth with that phone switch. So keep in mind, again, that's one or the other. Once we tell it where to start talking and begin that communication with the phone switch, the next most important thing you program are those actual ports. What is it that you want the system to record? So we need to go in and program those trunk lines or those stations, whether they're digital stations or VoIP stations. We need to make the system aware of what it is that we have physically attached to so it can start recording those ports. All of that's done in this recording manager area. If you come down to recording manager, there are a few different things I want to show you here. First and foremost, recording port settings. Make sure that you're licensed for the appropriate number of devices that we're going to be tapping onto. This system's licensed for 115 stations, or trunk lines. If you're expecting to tap onto 12 T1s or PRIs, and you only see 20 total licenses in here, you need to give us a buzz because something hasn't been configured correctly. 99 times out of 100, this is going to be just fine. It's more a verification step than anything. Secondly, if you're using any physical boards for trunk side recording, you'd want to come in and make sure that you've set your spans. Now, we happen to be using one PRI here at OAISYS, so I want to come in here and check this board appropriately. So when I come to my signaling, I make sure that I'm set up for a PRI and that my encoding and framing are correct. In the United States, typically our encoding is B8ZS and the framing is ESF. Those would be your standards. But if we were plugging into a T1, we'd want to set up the coding and framing appropriately for all those different lines that are coming in. Just the system recognizes those trunk lines that are physically plugged in to those boards that we're tapping onto. The next major thing that you need to do is actually the programming of your trunks or of your digital stations or your VoIP stations. That's all done in the little Program Ports tab. Here you're going to individually be enabling those ports that we're going to capture audio off of and telling the system about what those ports are. So for our example here, we're actually going to use trunk numbers. So port number 1, I'm going to enable that port and we're going to plug in the first trunk number that's on that PRI. The naming convention of that PRI trunk is going to vary depending on the PBX. Sometimes it's alphanumeric, sometimes it's numeric, sometimes it's alpha. It's a combination of whatever's programmed in the PBX itself. The most important thing to do is make sure that the trunk numbering scheme matches exactly what's been programmed in the PBX. If we're doing a digital station or a VoIP tap, this programming screen is actually going to look quite a bit different. In that scenario, we would set this up to be a VoIP tap type. You would type in the numerical extension number of that VoIP station that we're tapping onto, and then you choose the installation model or VoIP capture type of your PBX. With that determination made, oftentimes you're going to type in the IP address or the MAC address of the phone so it can start monitoring that actual key set for any audio that would be taking place on that phone. So depending on what type of audio capture we're going to be doing, the programming of the voice ports is going to look different for that particular configuration. Once you've programmed all those trunks individually that we're going to be tapping onto, or you've individually programmed all those stations that we should be monitoring for, the last phase of making sure that the audio is going to be recorded is coming to this check port screen. Here's where you get a real-time indication of exactly what's going on inside of the company, and here's where you can see whether or not everything's been programmed accordingly. As you can see from our check port screen, we have programmed in those 23 trunk lines of the PRI, and I can see in real time exactly what's going on with those 23 trunk lines. Currently, one of them is being recorded, and the other 22 are just sitting idly by waiting for somebody to pop on the horn. Here's where you can do your testing. If you grab a phone from inside of the organization, dial 1-800-FLOWERS, call Movie Phone, dial your cell phone, you should be able to see one of these lines go from idle to record. If you see that behavior take place when you place a test call, you know we're recording calls. The system's aware of when those calls are hitting the outside world, and it's recording the audio of those conversations. On a trunk side tap, your test call could go out on any single one of these trunks, so you would just be monitoring the entire set for a change in idle to record. If we're doing a station side tap or extension recording, that extension column would literally be labeled with the extensions that we're tapping onto and monitoring, so you would just go to any one of those particular extensions, take it off the hook, and you would be looking for that specific device to go from idle to record when you place the test call. If you see that behavior take place, we are recording that extension. Life is good. That's really all there is to the major programming on the installation side. We've got the system now aware of that phone switch. It's talking back and forth to the PBX, and we've programmed in those different trunks or stations to be monitoring, and the OAISYS system is aware of any activity taking place on those devices. The only other major things that really need to be done on the installation side. First and foremost, you want to get the system email capable. So if you come to the email tab, you can come to settings and you can type in the site's email server information. With that email server typed in, the system's going to get a lot of additional functionality, most important of which is the alarm generations. If the system's trying to tell you anything, you'll be able to receive alarms about that and you'll be notified of any issues that would happen. Email configurations also important for passing around recordings, sending out emails, evaluations. There are quite a few functionalities that are important to have this email server connected for, so it's a good idea to go ahead and program that during the installation phase of the server. In order to test and make sure it's hooked up to the web server appropriately, you can click on the little Send Email tab below, type in a valid email address in the To Recipient line, click the little envelope icon at the top, and you should receive a message that says email sent successfully, just letting you know that you've configured those email settings appropriately. And the last major piece of the puzzle that I like to talk about in the installation course is any network configurations that might need to take place for the site. Within the Network Configuration tab, just above the Lists and Other Resources folder, you can program all of the local client settings and all of the remote client settings. Specifically, the two tabs of interest over in the right are LAN and WAN clients. If you click on the LAN clients tab, here you get to program the range of IP addresses that will be able to locally connect to this OAISYS recording server. Some configurations want to limit this range of IP addresses. So if you only want the president or vice president's computers to be able to connect to the server to access recordings and use the features of the software, you might want to give them static IP addresses and just limit the range of connectivity to those specific IP addresses of the president, vice president, CEO, or whoever else needs access to the server. You can, however, also just blow the doors off of it and open up the local range of IP addresses as we've done here on this particular server. What this would allow is anybody with a local IP address to connect to the server, download the software where appropriate, and log in to work with the OAISYS recording software. Now, they would only be able to do so if they had a profile built for them in the software with a valid username and password. So you don't necessarily have to worry about anybody and their brother getting in there, accessing your recordings, and working with the software. Once you grant them permission access, build them a profile, they would then be able to use their username and password to log into the software and do with the software what you've told them they're allowed to do. More importantly, not do the things that you told them they can't do with the software. So the LAN clients tab, very important for connectivity among local users of the software. And the WAN clients tab is also very important if you're going to have people outside of your firewall having access to the server. People who might work from home, maybe they're vacationing and need full access to listen to recordings, or they're just a traveling salesperson that you never know where they're going to be, so any given time from any location, the Starbucks in Hong Kong, the McDonald's in San Francisco, they would be able to listen to recordings. If you want remote people to have access, whether they're everyday employees of your organization or even customers on the outside world that you might share recordings with on occasion, you have to appropriately configure this WAN clients tab. There are two major things that you're going to need to do within this tab and within your network in order to make this happen. First and foremost, you have to program for your server a resolvable host name from the outside world, a web address that anybody can browse to in a common URL browser to resolve to your server under your roof. Secondly, you need to open a port on your firewall to allow that traffic through. Once you give the server resolvable host name and you open the port on your firewall, most of which takes network programming, then you'll have a tunnel by which anybody on the outside world can have access to your server where they can download the software and work with recordings. Again, they would only be able to have that access if you've created them a username and a password and you've granted them permissions to work with the system. So it is still very secure, but nonetheless, we can give access to people on the outside world. That then will do it for our installation course. We do certainly go into greater detail about the administrative configurations through our series of administrator classes, where we take a look at things like programming recording rules, backup and archive, programming alarms, setting up user profiles, and doling out permissions. But in terms of just getting this server up and running and recording calls in its most basic form, those are the things that need to be done. Physically connect, make the system aware of the PBX, make the system aware of those different trunk lines or extensions that we're going to be tapping onto. So with that, I thank you very much for participating in this installation class. If you have questions about any of the topics that were covered, please feel free to be in touch with us via our website, www.oasis.com, or calling into our 800 number, 888-496-9040, where you can be connected to members of the training, tech support, or sales departments. Thank you very much and have a nice day.